Hi, it's Carly McAvoy talking about combinations and permutations. Combinations are a way of ordering objects when the order does not matter. As an example, if there are 4 people and I'm going to choose 2 of them to win $10, it doesn't matter if you're chosen first or second. You both get $10, so order is not important. How many ways can I choose 2 people? You would want to use your calculator for these combination and permutation problems. I'm going to show you how to do this out by hand, but you can easily do this on a calculator, and I posted a video that shows how to do that. So a combination of there's 4 different people, and then the second number r is the number that we're going to choose. So we have 4 people, we're going to choose 2, and there's 6 different ways we can do that. And the formula for that is n factorial, and n was 4, so that's 4 factorial over n minus r factorial. Well, n is 4 and r is 2, so 4 minus 2 is how we get 2 factorial in here, and then 2 factorial again. 2 factorial is just 2 times 1, so we have 2 times 1 from this and 2 times 1 again. On the top we have 4 times 3 times 2 times 1, and that's 24 over 4, which is 6. So there's 6 different ways I could choose 2 people out of 4. Okay. Permutations. When you are a way of ordering object when order matters. You have 8 people in your department, and you're going to choose 3 people for awards. Second runner-up will get a special parking place for the month. The runner-up will get 1 extra day of vacation, and the winner will get 4 tickets to the Mariners game and a $500 bonus. It's going to feel different if you're first, second, or third. So order matters. This is a permutation. We have 8 people, that's our n, and we're going to choose 3 of them. So if you do 8 choose 3 for a permutation on your calculator, you get 336. That formula is a little different. We have both of them up on the screen. Notice this has an extra r factorial. This one does not. We have fewer choices when we're doing combinations because 1, 2, 3 is the same as 3, 2, 1. But in a permutation, 1, 2, 3 would be different than 3, 2, 1. So we get more options with the permutations. We're doing 8 factorial on the top and then 8 minus 3 because those were the 2 numbers we're working with, which is 5 factorial on the bottom. You can see that the 5s, 4s, 3s, 2s, and 1s would cancel. What we really have is 8 times 7 times 6, which is 336. So that's the main difference about permutations and combinations. Whether the order matters, it's a permutation. If order does not matter, it's a combination. Well, let's take a look at this little cartoon that I found on mathplane.com. So it says these are the dining possibilities, and in the menu they have a combination plate, 1 course, salad, soup, entree, and dessert. So there's 4 things, they're all going to be chosen, and he's going to bring it out all at once. She's wanting the combination plate, so you get everything all at once. You're choosing 4 things, but you're not trying to arrange them in a certain order. That's not important. It's just there's just 4 things. On the other hand, the permutation meals has 4 courses, and you can see salad, soup, entree, and dessert, or you could have soup, salad, entree, and dessert. These are the same items, right? There's 4 items, soup, salad, entree, and dessert, but they're arranged in different ways. So suddenly we have all these different ways with permutations because the order matters. And so then she's saying, what do you suggest to my daughter? And he says, the number 4 is a big hit with kids. They like dessert first. So this is a nice little cartoon to say, if you don't care about the order and you're just going to get it all at once, that's a combination. If you care about the order and you're getting 1 at a time, then order matters, and that would be a permutation. Okay, thanks MathPlane for that one. All right, the next thing I want you to do is, given a scenario, decide whether it's a combination or a permutation. The gold, silver, and bronze medals are won by 3 of the 65 contestants. The committee of 45 chose a president, a vice president, and secretary to represent them. The committee chose 3 members to be on the negotiation team. The baseball coach put 9 of his 20 players into the batting lineup. She selected 4 of the 15 children to be trees in the spring pageant. And of the 19 local restaurants, 5 were chosen at random to be inspected. So those are all different scenarios that either involve a combination or a permutation. take a second to think about it before I give you the answers, because you want to be able to do that on your own. You may want to pause the video and try it. I don't know why I have extra space here. Okay, so if the order matters, if things are arranged in a certain way, then that's a permutation. So what do you think about A? That's clearly a permutation, because whether you win the gold, silver, or bronze, those are three different things, right? So we have 65, choose 3, and that's a permutation because the order definitely matters there. The committee of 45 chose a president, vice president, and secretary to represent them. Does the order matter? You're going to choose 3 people. But one of them gets to be president, and the other one's vice president, not nearly as cool, and the secretary, that's just work. So obviously, it's different to be a president, vice president, or secretary. So that's going to be a permutation because the order will matter. That same committee chose 3 members to be on a negotiation team. Well, you're a member. If you get chosen, you're a member of the team. You're not anything special. You're not the secretary, which does the most work. You're just on it. You're just there. So obviously, the 3 members on a negotiation team would be a combination, because the order doesn't matter. If you're chosen, whether you're first, second, or third chosen, you're still going to be just a member of that team. The baseball coach put 9 of his 20 players into the batting lineup. This one may be a little unfair for people who don't know anything about baseball, but when you're batting, the lineup matters. You've got a person who's fast that's batting first, and the 4th person is your cleanup hitter. So batting lineup, the order definitely matters. So that would be a permutation because it matters who gets to go first in the lineup. You're going to go first, second, third, fourth, or maybe you're all the way down number 9th on the lineup, right? All right, she selected 4 of the 15 children to be trees in the spring pageant. Well, if you get selected to be a tree, you're just a tree. There's no one tree that's better than any other. So this is just picking 4 things. They all get to be trees. That is a combination. Of the 19 local restaurants, 5 were chosen at random to be inspected. Well, if you get chosen, you're going to be inspected. The first person chosen is not going to get anything different than the 5th one. They're all going to get the same inspection. So that's a combination. So in case you didn't catch that or want to write that down, we're talking about the answers are here. You can maybe get that up on the same page so you can see them together. Combinations were C, E, F, and permutations were A, B, and D. Okay. Couple of examples of permutations and combinations. In a lottery game, the player has to choose 5 numbers correctly to win. What is the probability of buying 1 ticket and winning the jackpot if they can choose numbers from 1 to 40 without repetition? That is without replacement, right? This is not just asking how many ways they can pick numbers. This is asking what's the probability, so you have to go one step further. But is it a combination or is it a permutation? Well, you don't have to get the numbers correctly in order. You just have to choose the 5 correct numbers. So it's a combination. And you've got 40 numbers and you're choosing 5. And then there's 658,000 ways and 8 to get that. And so with 1 ticket, the probability of winning would be 1 over 658,008. So this is the extra step. When they're asking for the probability, if you bought 1 ticket, you have 1 chance out of all these chances of actually winning. If there are 3 people at your work site, what is the probability of a stranger randomly correctly ordering you from most experienced to least experienced on the first try? So there's 3 of you and somebody walks up and says, hey, I bet you've been working here the longest. Would they get it right? Well, that's the probability. And again, they're just taking 1 guess at it. This is a permutation because it's different if you're the most experienced, least experienced. That's a different thing, right? So we're ordering you from least to most. And so that's a permutation. But we have 3 people and we're choosing all 3. We're going to line up all 3 people. 3 choose 3. There's 6 different ways to do that as a permutation. If you got 1 guess, then you'd have a 1 in 6 chance of getting it right the first time. So that 1 in 6, that's just a probability that we've been looking at in previous videos. And then finally, how many different ways can the word Mississippi be arranged? There are 11 letters in the word Mississippi, so we could say 11 factorial, except that we can't because there's 4 S's, 4 I's, and 2 P's in Mississippi. So what we have to do when we're doing that, we do 11 factorial on the top, and then on the bottom we put a factorial for every letter that's repeated. So we have 4 factorial because there's 4 S's, and 4 factorial because there's 4 I's, and then 2 factorial for the 2 P's. And if you did that calculation on your calculator, which is how you should be doing it, you get 34,650 different ways to arrange Mississippi. And the last thing I want to say in this video is about simulations. Often it is not possible to create an actual situation because of the potential harm it may cause or the cost it would incur. In those cases, researchers can use simulations. A simulation of a procedure is a process that behaves the same way as the procedure so that similar results are produced. You can use random generator programs like this one that I have listed here, or your calculator to produce random numbers. But humans do not create random strings of numbers even if we try, because we tend to favor some number over others. Let's go to this website and see what it is when we try to use this to simulate flipping a coin 10 times. We're going to use 0 for heads and 1 for tails. So here's our random number generator, and right now it says the minimum number is going to be 1, the maximum is going to be 100. But I'm going to go and make that 0 and 1. And every time I say generate, that's going to be either a heads or a tail. So maybe I can keep track of this over here so I don't forget. So let's generate. So we have 1, that's a tails. And then we generate again. 0, heads. Generate again. 0, heads. Again. 1, that's tails. 1, that's tails. That's 5. Tails. 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 Heads. And heads. So in my generation there, I had 1, 2, 3, 4, 5, 6 heads and 4 tails. So that's pretty similar because we would expect 50-50. So a random generator is a way for you to simulate something without actually doing it. In my class, we're going to have an assignment where you have to use a random number generator, so maybe keep in mind this random.org. All right, have a fantastic day, and I'll talk to you next time.